Hey everybody, thank you for joining this week's Tech Talk. I am Brad, and today we're going to be talking about automated model deployment pipelines, specifically with MlFlow. So this is number 15 of the year, I think, if I did my math correctly. And we've had a lot of great talks so far, and looking forward to a lot more great talks coming soon. So maybe depending on the time we finish, I may have a minute or two to chat following this. So today we'll talk about automated model deployment pipelines, more on that in a minute. Next week we have a really great talk on designing APIs for AI. You'll hear from our head engineer here at Modzy talking about our experience and kind of some of the challenges of building a software specific for machine learning and MLOps. And at the end of the month, we will talk about Chassis ML again around our launch of the publicly available version. So you won't want to miss that. So some of you may remember a talk a couple months ago that was also titled Automated Model Deployment Pipelines, which you were correct about. However, in that talk, we focused on AWS's SageMaker product, which is a very common training product that a lot of data scientists leverage to build their models. And today we're going to focus on MlFlow, which is in the same family in terms of tools and capabilities, but a different model or a different tool. We also talked a lot before we got to the demo about the bridge between data science and DevOps. Or MLOps, and we're not going to focus on that as much today. I don't want to repeat myself. So instead, I decided that we will focus a little bit on MlFlow, the product, because it's a tool that provides a lot of really great utility to organizations. So we'll do a pretty thorough intro of MlFlow, and then show a demo of training a model, tracking it using MlFlow, watching the experiment as it progresses, and then taking that trained model and automatically deploying it into Modzy. The reason this is important is because once models are trained, sitting on a laptop as just a pickle file or a checkpoint file, it's really hard to replicate the environment and deploy that into production. And that's what what we'll do today, using what we call the Modzy Model Converter Service. So with that, let's dive into MlFlow and talk about what it is a little bit. First, it's an open source platform that allows data scientists and organizations to manage different components of the machine learning lifecycle. Speaking from my own experience and on behalf of the whole Modzy team, we leverage MlFlow for a ton that we do here. It's again provides a lot of utility, and it's a very valuable tool for various aspects of the machine learning lifecycle. A little bit of background. It is an open source project, as I mentioned. Databricks, which is obviously a leading data warehouse and data lake software that we all know and hear, introduced and released this open source project back in the summer of 2018. And today they remain the primary maintainers of this product. They had worked with hundreds of their customers who were experiencing issues when it came to machine learning, and that inspired them to build this open source project. The first was that, unlike normal software where typically you can just get away with using one software as opposed to others or competitors for different use cases, when it came to machine learning, there are hundreds of open source tools that help make a data scientist's life easier. And to successfully build a machine learning pipeline, you can in some cases use 5, 6, 7, 8 of those different software packages all in the same workflow. And that presents a big problem because you may be using PyTorch, scikit-learn, NumPy, Pandas, different hypertuning libraries, and they all work together, but the outputs of those different functions behave differently. The syntax is different, and so it presents this really tough challenge of how do we consistently monitor and track these training experiments as we build them. So that was one of their main kind of pain points that their customers were experiencing. Moreover, they found that it's really hard to reproduce results without detailed tracking. So, one of the primary motivations was to build this really, really great tool. It's open source that integrates with tons of very common frameworks and tools, and then gives data scientists organizations an awesome way to standardize and centralize the tracking of all of their training experiments. So that leads us to today. It has evolved a lot, as I mentioned, and there are 4 main components to the MlFlow project. First is MlFlow tracking, which gives you the ability to record and query experiments very easily in an awesome interface that I'll actually walk through a little bit later. The second is MlFlow projects, where it gives you the ability to package data science code in reproducible formats. The third is MlFlow Models, which some of you may be familiar with. It's the idea that you can save any model trained in scikit-learn, PyTorch, TensorFlow in one standardized general output, which is really powerful because it then allows you to make the loading of that model and inference of that model standardized, something that's a big problem. So we'll talk about that a lot more later. It's actually one of the foundations of Chassis, which allows Chassis to do its magic. So we have very much benefited from that particular component. And the last is MlFlow Registry, which gives you a way to store and manage all of your MlFlow models once you've trained them. Something that I've talked about a couple times now is integrations, and MlFlow really took this seriously when they were building this product to integrate with as many common machine learning frameworks, tools, platforms as they could. And these are integrations that they have formal plugins to today, which is great. Makes it really convenient if you're working with any of these tools to produce a reproducible or construct a reproducible machine learning pipeline. Additionally, there are tons of using and contributing organizations. This is directly from their website, and you see, big blue chip companies, the big tech firms, various other types of companies, data from the data world, the machine learning world, including ML ops and model ops. Modzy is on here as well. Again, as mentioned, as we leverage this really powerful tool quite often. So shifting gears a little bit from MlFlow to the relevance of its use utility today with Modzy. I showed this diagram a few months ago when I gave a talk to showcase the different ways that you can get a model into Modzy, and there's a few of them. We've seen Chassis in a few talks at work. But what we're going to showcase today is the model converter service, which is the idea that if you've used one of these 3 very common platforms, SageMaker, Azure ML, which is the SageMaker equivalent, or MlFlow, you can just take those raw outputs, stick them into our converter service, and you'll get a fully deployed model into Modzy. So taking that one step further before I dive into the actual demo, we will conduct an experiment. Here's a little sneak peek of the UI, where the output of that experiment will be an MlFlow model, which is saved in this format. You'll notice and I'll walk through this in more depth, but there is an ML model metadata file, describes some important information about your model, a conda.yaml file. This is great because it actually infers the packages needed to run that model in production, and it makes reproducing that environment very easy. The model file itself, in this case the model.pickle file, and then an optional requirements.txt for additional dependencies not defined in that conda.yaml file. So again, we are going to be leveraging these 2 components heavily today of MlFlow. And then we will use the converter service to deploy that model directly to Modzy. There's lots of benefits for doing this and deploying directly to a model ops platform that specializes in production inference through REST APIs. It's very easy to use, in addition to an entire collection of monitoring and managing capabilities that we offer. So with that, it's time to jump into the quick demo. Let me switch my screen over to my notebook, where you should be seeing MlFlow. Looks like we're good. Okay, so before we dive in, I'm going to show you the couple tabs I have open. First is the MlFlow tracking UI. So as you can see, it's a very user-friendly interface, and we'll come back to this in more depth later. I've got an S3 bucket open. We'll need this to deploy, or rather I knew this was going to happen. Let me sign in again real quick. We'll need our S3 bucket to store some model outputs in for the converter to access when we get to that point. So we go here. One second here. I'll just configure this real quick. MlFlow. It's being slow for me. Oops. There we go. So we'll come back to this in a little bit later once our training experiment's finished. We have our YAML file, and this is Modzy specific. We will use this to define some important metadata about our model before passing it through to the converter. And then lastly, we have our Jupyter notebook that will be the main driver of this experiment. Okay, so what does this MlFlow tracking capability look like? As we can see here, this interface allows me to create and manage experiments separately and segmented. And for each experiment, I can see how many times that I've run an actual training job. Now, there's a lot of useful information here, including when it was started, every run, whether or not it was successful or not, with either a check mark or an X indicating the status, the amount of time that the training run took, run name, which is a parameter that I didn't configure for any of these runs, the user, and then the source. You can see different training scripts directly in my machine, in addition to some Jupyter notebooks that I drove some of this from. And then we can see the models, and then most importantly, we can get over to the metrics and parameters sections. So this, again, is one of the most useful parts of MlFlow tracking. Data science is a very experiment-heavy practice. Data scientists do all these great things with big data and large data sets, and they transform that data, they augment it, they clean it, and then they use that data to train machine learning and deep learning models. Well, there are lots and lots and lots of ML and DL, deep learning frameworks out there, architectures, all of which are configured differently, have different architectures, and most importantly, have various different parameters. Well, a common practice for data scientists is to set up experiments where they test out different combinations of parameters, also known as hyperparameter tuning, to achieve the best accuracy and performance of that model. And that's where these metrics come into play. I'm just showing you one reference example of different runs you could execute, but in metrics, parameters, tags, all this is entirely customizable. Now, again, as a convenience function, MlFlow has built direct logging support to a lot of the common frameworks. So PyTorch, scikit-learn, a lot of these were auto-logged, but you can manually configure this as well. If I click into the result of one of my ML runs, is what they're called, we see more information here. I could document in detail what's going on in this particular training experiment to be stored later. I can see the parameters that went into this particular neural network when I went to go train it. I can see the metrics that were logged, so I can see the average test accuracy, which I think was only computed on one epoch, or validation loss. Again, this was a very quick training experiment. I only trained it for 4 epochs. So you can see the validation loss as epochs increase. And then lastly, we have this section down here where out of the box, MlFlow provides some copy-pastable code to run this newly trained model either on Spark or on a Pandas data frame. And this is great. It can reference that model directly in a locally saved file, load that model in. This is one of the really powerful tools that and functions of MlFlow model, the generic format. This is great, but it's not necessarily the most scalable when you're talking about reproducing this environment and taking this model output and running it in a production application. So this format, again, I referenced this earlier. We can see the ML model file directly, where we see it's a MlFlow PyTorch flavor, the UID, the run ID, also some important metadata. This YAML file, again, we can use this to very easily reproduce the environment where this model needs to run, and then some additional requirements if needed. I'll show you one more quick example that I actually didn't fully finish, but a larger example where you can see, in this case, that I think we trained it for 25 epochs and see the training loss over time, and it's definitely decreasing, which is what we expect, but this model needed a little bit longer to train. Now, another really useful application for tracking is you can plot 2 different sets of hyperparameters for the same model on the same graph like that, and see kind of how they match up really easily. So, quick rundown on MlFlow tracking, but it's time to now execute an example run ourselves. So we're going to use the use case, the example use case today, that I may be a restaurant owner or a purchaser or buyer for a boutique store that wants to sell wine in a town. And my goal is to find very high quality wine that maybe nobody knows about or is generally cheaper than the well-known brands. Keep in mind, I know nothing about wine, right? And so what we're going to do is we're going to train a model based on this data set right here. It's a tabular data set where there are about 5,000 entries, and based on the chemical balance and makeup of every wine, there will be a quality assigned to it. So again, entirely numerical. We will use an elastic net, which is a variation of a linear regression, to train this model to tell me what the likelihood is that the quality of wine based on its chemical balance. So with that, we will start by importing some of our required dependencies, namely scikit-learn and MlFlow. We need to set the tracking URI. This is just basically where all of the experiment output and artifacts are stored. And then we'll create a brand new experiment. We'll call this wine quality prediction. And this ID here is just to make sure that it differentiates from the other experiments I've run, again, in this ML runs. Hopping back over to the UI, we should see a brand new experiment show up down below. And so now as I run different training experiments in this, with this experiment, they will show up here. Okay, so we'll set our experiment to the one that we just created, this wine quality prediction, and define a single train function, where in this train function we will calculate some metrics that we use to evaluate our model performance, read in the data, split the data into train and testing subsets, drop the quality variable because that's what we're going to be predicting. And then with this simple MlFlow start run, we can start executing this experiment fully logged and tracked using this MlFlow tracking component. So again, we're just loading this in directly from scikit-learn. This elastic net will take 3 parameters, but the 2 that we're interested in that we'll hypertune and play around with is this alpha and al1 ratio parameters. And then using this MlFlow log param and log metric syntax, we will specifically log the parameters that we inserted to this model and the metrics that we're using to evaluate it. Okay, so let's execute this. So our training function is now defined. We will kick off 3 training experiments right here. And we see the root mean squared error, the mean absolute error, and the r-squared value printed to our screen with these different alpha and L1 ratio values as parameters here. So this is great, but what we can also do is go back into the MlFlow UI, and after a quick refresh, see all 3 experiments show up right here for us. And I guess we can see how long they took, all fairly quick. But as an example to illustrate what I was talking about earlier, we can very easily compare the performance of our models based on the parameters that we specified. And so for linear regression models, we're looking for a smaller mean absolute error and RMSE. Typically that would imply a higher accuracy for the model with a higher r-squared value. And so it just so happens that this first set of parameters produce that most desirable model output. So that means I'm a data scientist now, and I've experimented, and this is good for now. So I'm going to take this run ID and say that this is the best run that we want to package up and deploy using the Modzy API. So we'll kick off this run. We'll ensure that the artifacts are indeed where we want them to be. Again, this should be a familiar format. And we will, again, start importing some packages. I've already defined some cloud credentials we need to access the buckets with the resources. And then we will do one last thing before kicking things off. And that is defining a weights key. So I'm going to kick this off because it does take a little bit, 3 minutes or so, and explain what I did after. So first thing we're doing, we're taking the raw outputs right here. Again, the MlFlow model format. We're wrapping them up in a weights tarball and sticking them into our S3 bucket. So if we refresh, S3's being slow for me today. We get we see the resources, which is our YAML file, and our weights file, which is the raw output of that MlFlow experiment, as I just mentioned. Next, we will instantiate the model converter object through the Modzy API client. And to do so, we just need our URL that we're pointing to and API key. And then once that's all happened, we will kick off our job using the start command, pass through our credentials so that credentials and specific paths to the resources, pointing directly to these resources in our S3 bucket, indicate that we're converting an MlFlow model and it's a tabular data. And then I just executed this block until complete, and so we should wait in about a minute or two. This job will be complete. In the meantime, we could have done this entire thing in the Modzy UI. So I'll just show you what this looks like very quickly. I know we're running up on time here. The idea is you could take a model, however it's built, and build your own container, automatically deploy it using chassis, or just insert the raw artifacts into our converter service and deploy it accordingly. So in this case, we will specify that our resources are in an Amazon S3 bucket. We will make sure that we copy over the bucket name correctly, MlFlow deployment. We have to provide some credentials so that the converter can access the resources. So copying these in. Indicate that we're working with a tabular model. And then we have to paste in the same paths that we defined here. So MlFlow wine weights. Again, this is our MlFlow model. And the same thing with resources appended instead of weights. and saving and continue would do the exact same thing that we're doing programmatically. Now, as this finishes, wanted to just talk about the value of this automated deployment pipeline. As I mentioned, we started from nothing, from not having a model with just a data set. And we trained that model, we monitored it, we compared a few different experiments to take the highest performing model. And with just a few lines of code, we were able to deploy that model into a production application, where you can then use a few lines of code at the very bottom here to see what data we're working with. Again, this is omits the target variable column, and just a few lines of code we can submit an inference to this model. I kicked it off about 4 minutes ago. It should be finishing any second now. Let me just check real quick. Yep, and it just finished, and so we see that it took about 3.5 minutes, and our newly deployed model is available to us right here, where we've got the description. I forgot to change the name in the YAML file beforehand, but again, we can now hit that model. It's its own REST API endpoint and very easy to use. So I know we're coming up on time, and I will stop sharing my screen. Thank you, everybody, for joining.